All right, good afternoon, everyone. Today we are going to work on chapter 15. We're going to start simulation models. So far, we have worked with different kinds of optimization model. In optimization, objective is to maximize or minimize uh, the objective variable and also meet some constraints. But in simulation, we have some uncertainty in one or more input variables. And we try to model this uncertainty with probability distribution. Okay? In the opening case of this chapter, you see that America West, which was an airline later merged with US Airways, and they're both currently known as American Airlines. They try to use simulation models to minimize and their turnaround time. Turnaround time is the time between when the flight lands and when it departs the airport. So they used the simulation models, and they ended up minimizing their turnaround time by 37%. So in this model, they want to minimize their turnaround time. Several factors contribute to this time. This is the time between when the flight lands and when it departs. And the point about turnaround time is that airlines lose money as their planes are on the ground. They try to minimize this turnaround time. And the factors that affect turnaround time are like cargo loading and cargo unloading, plane maintenance, luggage loading, unloading, and etc. And we have one important factor, which is passenger boarding. The problem here with this kind of example is that the airline has control over all these factors, like cargo, loading, plane maintenance, and etc. They can minimize, they can kind of design new methods and models to minimize the time. The factor that they don't have control over is the passenger boarding. They cannot force passenger kind of to board in a certain order, because customer satisfaction is very important. And at the same time, they want to minimize the boarding time. Some of the passengers may stand in the aisle and talk to each other, and they may delay the flight. So they use simulation to simulate passengers' behavior to be able to minimize their turnaround time. So at the end, they were able to minimize the passenger boarding time by 37%. So in this type of model, we don't have kind of real number, and we try to simulate these kind of uncertain variables with probability distribution. Okay. So in this chapter, you are going to be familiar with different kind of probability distribution and how to develop a simulation model and get the optimal value for your objective variable. So in the simulation model, We use input variables, input and output variables. Instead of using one value for the input variable, we use a set of values, x1, xn, with their probability distribution. Probability distribution means the value, uh, the possible values that a variable can take on, and its corresponding output, y1 to yn. So probability distribution is its value and its probability, Tn. So each of these input cells forms a kind of scenario. We use multiple scenarios and we feed it into our model and we get some output results. And based on the results, we determine which one is the best case scenario and which one is the worst case scenario. So scenario is a set of inputs with their probability. So we examine these values and their corresponding output to see which one works better. So here's the definition of the simulation model. It's a computer model that imitates a real-life situation. It's very similar to other mathematical models, but the difference is that we have uncertainty with one or more input variables. We don't have access to the real data. So its advantage is that it provides an entire distribution of the result, not a single value of the result. And each set of values for the uncertain quantity is called a scenario. So we use probability distribution for uncertain input. We send it to the simulation model. We get some output from that model. And we can use this model's simulation model to check the sensitivity of the simulation model. And we try to simulate uncertainty with probability distribution. We can classify our probability distributions by these factors. Each probability distribution can be discrete versus continuous. Or it can be symmetric or skewed to the right or left, bounded versus unbounded, and non-negative versus unrestricted. For example, this is an example of a discrete probability distribution. Discrete distribution has finite number of values between each pair of values. Suppose this is our x-axis and this is 1. Between 0 and 1, our variable can take on these values. Can take on only 3 values. It is called a kind of discrete distribution. The number of values between within a certain interval can be counted. In telecommunication, it is called a kind of digital number. Digits separate, discrete. But in continuous model, our variable can take on an unlimited number of values. For example, between 0 and 1, we have 0.0000001, 0.000, unlimited number of values between a pair of numbers. That's the difference between discrete and continuous. In telecommunication, we call it an analog kind of signal when we speak. Our voice creates an analog signal. Microphone receives that signal and converts it into this kind of form, which can be used by computers. So anyway, here's a normal distribution. Is an example of the continuous distribution. It is identified by the mean and standard deviation. Mean and standard deviations, these two tails. A distribution can be symmetric, like this one, or it can be skewed to the right or skewed to the left. We have discussed these topics in chapter 3, skewness and etc. And bounded versus unbounded is pretty straightforward. Non-negative versus unrestricted and etc. So the common probability distributions. In uniform, this is a uniform distribution. It is identified by two values, minimum and maximum. It's a kind of flat distribution. We can model it in Excel with rand function. For example, equals it gives 92%. Let's press F9. We get new results. With F9, each time you press F9, it gets refreshed. It takes new values. And rand between 1 and 6. These are two examples of the uniform distribution. Discrete distribution, we've already discussed it. And, here's the normal distribution. It has two parameters, average and standard deviation. It's a kind of bell-shaped curve. And we have triangular distribution. It has three parameters, minimum, maximum, and most likely value. And we have binomial distribution, which is a kind of discrete distribution. So now we want to work on this example, ordering calendar at Walton, to see how a simulation model works. Let's go to by the way, I uploaded some videos on risk at Inst tutorial. You can watch and learn how to use this probability distribution in Excel. These are 4 videos. But let's go to example. Float average. The software tool that we use for simulation is Risk, which is part of the Decision Tool Suite package. Which is an add-ins to Excel. Risk add-ins. Risk stat tools are part of the Decision Tool Suite. And let's see if we get the risk. Yeah. If you click on this risk, you will get a tab named Risk. It has all the tools available for simulation. So here in this tab, we can work with different kind of distributions, define. We see different kind of distribution with their parameters and characteristics, normal, arc, triangular, uniform distribution, continuous, and discrete model. So now, let's go through this example. Ordering calendar at Walton Bookstore. Please read this example from your textbook, and then I will show you how to work with this example. In this model, we want to see the difference between deterministic model and non-deterministic. In deterministic model, we use one value to model uncertain variables, but in uncertain inputs, we need to check multiple values. Okay? This bookstore wants to decide how many calendars to order. Each calendar costs $7.5 and sells $10, and each calendar can be returned and be refunded $2.5. They believe that ordering the average demand is 200 calendars for this year. Is that a good decision that they go and buy this calendar or not? In this model, we have a deterministic model. Deterministic means we have one value. That's their best guess. They predict that customers will buy 200 calendars. We want to compare it with a set of input variables. That's their best guess. And we want to compare the result of this model with the situation where we have number of input variables and see which one is close to reality. These are the input variables: unit cost, unit price, unit refund. Their guess is that 200 will be the customer demand, and the order quantity is 200, and they want to kind of maximize their profit. So we have uncertainty with this variable, with demand. That's their guess. Here is a deterministic model. We have one variable. Let's calculate the rest. So revenue equals Unit cost, let me define name for these variables. Unit cost, we go to formula, unit price, unit refund, order quantity, revenue equals unit cost times I think the difference between minimum of the order quantity and demand. Unit cost times demand, minimum of the demand or order quantity. Okay. Cost equals unit price times order quantity. Unit price times order quantity. Refund equals unit refund times the difference between order and demand. Order quantity minus demand. And profit equals revenue for C16 minus cost minus D16 plus refund plus E16. Unit refund times order quantity minus 0 cost unit price. Oh, sorry, unit cost. Unit cost. Revenue must be unit price. So here in this model, with this forecasting 200 as their demand, they can make $500 as their profit. Okay, so here we just take one value as our demand, but we don't know whether it is correct or not. This is our expectation. The other way is to take set of input variables, kind of probability distribution, and see how this model works. In the simulation model, I'm going to copy all these formulas to our new model. Equals B9 Control C, Control V, Control C, cost again, Control V, refund, Control C, Control V, same for this one. But in this model, in simulation model, which is a non-deterministic model, we don't put any values for the demand. We try to model it with a probability distribution. We can use a normal distribution with mean 200 and a standard deviation of 400. So we should enter equals risk normal. It has two parameters. First parameter is the mean, which is 200, and its standard deviation is 400. Okay. Risk normal produces normal distribution with numerous values. And let's press F9. We get new results. Okay. So now, in this model, we need to define profit as our objective variable or output variable. We define profit as our output variable. Okay. This part has been added to our formula. Risk output, and this is the probability distribution for our input scenario. Now let's run our model to see what outputs it can produce. Start simulation. Here's the demand, and let's get the output. Risk output profit. Risk normal. It is working right, but it does not produce the correct results. We should produce number of output variables, not a single value. Setting number of iteration, number of simulation, 1. Risk normal. profit is the output. Now we get the same result as the deterministic model, but I think there is some problem with this model. It has to produce number of output values, not a single value. We have only one value here, 500. This value varies between 447 and 500. Let's check other distributions like risk triangle, minimum, maximum, minimum, most likely is 200 and maximum 300. F9. For both distribution, it produces the same result. There is something wrong with this risk. I have to double check and see if this risk is working right. So here we have kind of triangular input, but the result is the same as the normal distribution. It should not be this way. Let me check this risk package, and I will try to develop the same model on Friday. I will upload the correct solution to this problem. So the result should not be this way. Result is the same as normal 200 and 40. Some risk. Here is the output variable. The result is very similar to the previous model. It should not be this way. Let me double check this risk, and then I will develop the correct model on Friday. But in any case, we have to define our demand or our uncertain variables apart from the results. We have to define a probability distribution for the uncertain variable, and we have to define our output variable by this menu, output menu, and then run simulation. Here we selected number of iterations. Simulation is the number of uncertain variables. Here we have only one uncertain variables, and it has to create some scenarios for the output variable, but this model is not working. I don't know why. I will figure it out. Yeah, that's all for today. Thank you all for coming.